Hello class, welcome to Geometry Lesson 10.5, Secant Lines and Segments. So our essential question for today is, how are the measures of angles, arcs, and segments formed by intersecting secant lines related? And our goal is to use angle measures and segment lengths formed by intersecting lines and circles to solve problems. So our vocab term is going to be the secant. So let's go ahead and define that. Well, first, remember that in a previous lesson, we talked about tangent lines. A tangent is a line, ray, or segment that intersect a circle at exactly one point. For example, point E here for a tangent line EF. A secant line, however, is a line, ray, or segment that intersects a circle at 2 points. So for example, EF is a tangent line crossing at point E. AB and CD are secant lines crossing at CD and AB. So let's talk about our first theorem for secant lines. If I have two intersecting secant lines, then I can figure out the angle between those secant lines by taking the intercepted or arcs here, so this intercepted arc for that angle, and the intercepted arc on the other side of it, and I can add them up and divide by 2. If I take half the sum of those intercepted arcs, that gives me angle 1. So for instance, if I knew that this intercepted arc is 60 and this one is 40, I can add them up, divide by 2, and get 50 degrees, and that's going to be this angle here, 50 degrees. So let's apply that theorem with an example, a couple examples here. So we're given angle DWPX, or we're given ZPW rather, and we want to figure out WPX. Well, notice that these add up to 180 because they add up to a half circle here. So if I know this angle and I want to find this other angle, then I can subtract from 180 to get or subtract 93 from 180 to get 87 degrees. So now we know angle WPX. Now this time, if I wanted to find arc WX, now that I know this angle is 87, I know by the theorem from earlier that this angle has to equal half the sum of its inscribed angles, right? Intercepted angles rather, or intercepted arcs, WX, which I'll call X here, and the intercepted arc on the other side, which is 74. So I can add those up and take half of that sum to get this angle 87. So what I can do here, if I want to solve this equation for X, I can multiply by 2 on both sides. And if I multiply by 2 on both sides, this crosses out and therefore gets rid of the half. So I have 2 times 87 is 174, which is equal to X plus 4. So now I can subtract 4 on both sides, or 74 on both sides rather, because it's supposed to be 74. And I get X is equal to 100 degrees. Okay, so if we knew this angle, we can take half the sum of its arcs here, X plus 74, and then multiply by 2 to get rid of the half, and then subtract the 74 to get the arc. So now we know that arc WX is 100 degrees. So if I were to average these two arcs, 174, I should get 87. All right, let's look at another example, this time with variables all around here. So we know that this angle here is 15x minus 5, and we know by the theorem 1010 that this arc here and this arc on the other side, if I add those up and divide by 2, that should give me this angle here. So that's exactly how we're going to solve this. So we know that this angle has to equal half the sum of its intercepted arcs, the intercepted arc 24x minus 6 plus the intercepted arc on the other side. And we take that sum, we half it, and then we solve for x here. So we have here 50 minus 6 is 44. So we're just going to simplify here at this point. Next, we'll cut each of these in half. This will be easier to do now because these are nice numbers to deal with. So half of 24 is 12, half of 44 is 22. we got 15x minus 5. So we can solve this by subtracting by 12x on both sides and adding 5 on both sides to get 3x is equal to 27, which means x has to be 9. So now that we got x, we can plug it in to get arc LM. Arc LM is this blue one here, so let's plug it in there. So we get the measure of arc LM is equal to 24 times 9 minus 6. So 24 times 9, we have 9 times 4 is 36. We'll carry the 3 over. 2 times 9 is 18, plus 3 is 21. So it's going to be about 210 degrees. All right, so for Theorem 1011, the measure of an angle formed by two lines that intersect outside a circle this time is half the difference of the measures of the intercepted arcs. So before, when they crossed on the inside, we had to take the sum of those intercepted arcs. This time when they cross on the outside, here, we had to find the difference of the intercepted arcs. So that's the difference. If it's on the inside, you add up the arcs, divide by 2. If it's on the outside, you have to take the difference. You have to subtract the arcs and then divide by 2. So for instance, if we knew this arc is 50 and we knew this arc is 10, then I do 50 minus 10, and then I divided it by 2, and that would give me 20 degrees. And so this angle would be equal to 20 degrees, for instance. All right, so this works no matter which case you belong to. Case 3 is when you have no secant lines whatsoever. You have 2 tangent lines. Case 2, you have 1 tangent line and 1 secant line. In case 1, you have 2 secant lines. All right, so for example 3, find the measure of arc RP. So first off, we want to find this arc. So if we want to find that arc, well, we know that this is 152 and this is 126. And this, these 3 arcs, the blue one and then these other 2 arcs, add up to a full circle. And so therefore, I can get the blue arc by subtracting this by the sum of those. All right, so that's what we're going to do here. So this is equal to 360 minus the sum of 152 plus 126. So 152 plus 126 is 277, or 278 rather. And I take the difference and I get 122 degrees, or 100. Should actually get a small number here. Should get 82 degrees. All right, so 82 degrees plus 178, just to verify, that's 0, 1, so that should be a total of 360. So we know that this angle this arc has to be small, and it's 82. All right, so now we're going to find the measure of PSQ, which is this angle here. So using the theorem from earlier, Theorem 1010, one of the cases here, you're going to take the intercepted arcs, which is this one here, and this blue one on the inside here. You're going to take the difference between those 2 arcs and then divide by 2. So this is equal to half the difference of 152 and 82. Okay, so we got half, and then we got 152 minus 82 should be 70 degrees. And then take half of that, you get 35 degrees. All right, so it takes care of that theorem. So let's look at another example in which we utilize that theorem. So here we're looking at what looks to be case 3, where you have 0 secant lines. You only have 2 tangent lines. So you have tangent line TS, or this is a secant segment technically. This is a tangent segment TS, and then a tangent segment TU. So this time we got the angle. We're trying to find the arc. So remember that this angle has to be the difference between half the difference between this major intercepted arc and this minor one right here. Okay, so we're going to take the difference between those two different arcs here. Let's color code that other arc here. Let's color code that purple here. So we got to take the difference between the red and the purple arcs. Now, we know that the red arc is x. To get the purple arc, whatever x is, we subtract it from 360 in order to get the purple arc, because if the red and the purple, we clearly adds up to 360, a full circle. So if I know that the red is, say, 100, then the other one has to be 360 minus 100. So this is going to be 360 minus whatever x is. So now we can apply the formula here. The formula was that the angle on the outside has to equal half the difference of those two arcs. Half the difference of x and the purple arc, which is 360 minus x. All right, so now we got those two arcs there. We take the difference, cut it in half. Let's solve for x. So notice that we got x minus negative x there. Those two negatives turn into a positive. All right, so it's going to be x plus x. So it's going to be 28 equals 1/2. X plus x is 2x. Then we got minus 360. All right, let's cut each of these in half. So half of 2 and half of 360. Half of 2x is 1x. Half of 360 is 180. And then finally, I can add 180 on both sides to get the arc US, which is x here. So we add these together, we get 208 degrees. So now we know this angle, and therefore we know the purple arc. So now we want to find the purple arc, which is UPS. So what we got to do is we got to just do 360 minus x minus 208, and that will give us 152 degrees. All right, so let's look at a next theorem. So this time I showed you how to find angles when the secants intersect on the inside as well as on the outside. This time we're looking at the lengths of the segments when the secants intersect on the inside. Notice that when you have secant segments intersecting on the inside, you tend to make chords. So case 1 involves chords in which two secants intersect. And then for case 2, we have two secant segments intersecting as well, but it's on the outside, and we want to figure out the lengths there. Case 3, we have a tangent segment and a secant segment. We want to find the lengths. All right, so if you have two chords or two intersecting secant segments, you take the product of each side, and that's going to be constant. So the product of the lengths is going to be constant. So A times B equals C times D. For the case 2, if you want to figure out the lengths, you got to take the outside portion, which is n, and you got to take the product of the outside portion with the entire thing, which is n plus m. For the bottom, you got to take the outside portion times the whole thing as well and set them equal. Same thing for case 3. You take the outside portion, which is x, times the whole thing, which is another x. So that's really x times x, or x squared. Then you take the outside portion here, times the whole thing, and you get the same thing, z times y plus z. All right, so let's use the theorem here. So we want the value of a. So if we want to do that, we take the product of each side. So a times 4, and then 6 times 6. So we have 4 times a has to equal to 6 times 6. So we got 4 times a equals 36, divided by 4 on both sides. We get a is equal to 9. All right, so looking at our final example here, using the theorem, we said the outside segment times the whole thing, which is going to be the same number here, 45 times 45. So we got 45 times 45, which is the same thing as 45 squared, is equal to the outside portion, which is equal to 27, times the entire thing. And the entire thing is 47x plus 1 plus 27. All right, so then we're gonna go ahead and just do the math here. We got 45 squared. It's a pretty large number. So let's go ahead and let's calculate that first. We got 45 times 45 is 2025. we got 27 times 47 is 1,269x. Then this is going to be 28. So I'm going to call this 28 here. And we'll do 28 times 27. All right, so then we solve for x. We're going to subtract 756 on both sides. So 2025 minus 756 is equal to 1269. And so we divide that on both sides and get x is equal to 1. All right, so now we want to find AC. All you got to do is plug it into AC is this entire line segment. This entire line segment is AC. And so to find that entire line segment right here, all of this, you have to add 47x plus 1 plus 27. So AC equals 47x plus 1 plus 27. And then you can plug it in. We'll start plugging into that. 47 times 1 plus 1 plus 27. 47 plus 1 plus 27. So we got to add those together. Okay, 48 plus 25 looks to be about 75. All right, that's going to do it for the video, guys. I hope you found this useful, and I hope you learned a few things. As usual, I'll see you in the next one.